Let's look at at problem 2 of this sheet. And in this circuit, what you're being asked is, you said, okay, let's say you have your pulse signal that you made in the lab, and suppose you can put a threshold on your pulse signal so that every time a pulse appears, you get a square signal. Okay. Now you want to make a circuit that counts the number of pulses that are recorded, and you can see why that would be necessary, right? If you want to make a circuit that gives you the beats per minute as an output, what you can do is you can have this square signal. Every time a pulse comes, there's a square signal. If you count the number of square signals in, let's say, 1 second, that will give you beats per minute or something like that. Sorry, if you count the number of beats, pulses that come in 1 minute, you will be able to get the beats per minute or something like that, right? But in this case, the question is simply, how do you make a circuit that counts 16 pulse beats? And the answer, what is that circuit called? A circuit that counts till 16? It's basically a counter, right? So it's just a counter, and it's a up counter, right? So you count from 0, you count till 16 or till 15, so that's 0 to 15, so that 16 pulse beats can be counted. uh, and this is going to be a 4-bit uh, counter that you would need to do that. In part B, where you have to count 256 pulse beats, you will need a 8-bit counter, right? But how will you make this counter? Well, what you can do is you can take a counter, and perhaps one of the ways of doing that would be to go to multisim, and you get these circuits that are called counters, right? So you can just do binary counters, and you can see that you get these circuits that actually count. And in this case, these are counting A, B, C, D, so 4 values. Okay, or you can get another counter which does something similar. So here's a counter which this makes a little bit more sense. I was not sure what that is doing. So you have a 4-bit counter here, right? Similarly, you can get 8-bit counters, and you can use these 8-bit counters to count till 256. Now, and what you can do is this A, B, C, D can be adjusted so that the values are so that the counter is just counting up. And what we can do is we can connect the thresholded square signal to the clock of the counter. So I'm not really going to do the entire circuit. You can look up the solutions, but also we've done this kind of counters in the class. We've done 8-bit counters, but it can easily be extended into 16 and 256. Into 4-bit and 8-bit counters. Okay. So that's problem 2. It's a fairly straightforward problem if you understand that you need to do a counter there, right? So that's the tricky bit. So that's what I explained. All right. Take care.